Hey, Tom Peter likes math and history, and we are going to take a look at overlapping triangles. So, when you hear the word overlapping, you probably think of a piece of paper that kind of overlaps this piece of paper. Well, it's basically that definition, but instead with triangles. So this is a diagram given to us. The first thing I want to ask to make you start thinking is how many triangles are there? Well, you think that there are 1, 2, 3 triangles, but actually there's more. When there are overlapping triangles, there are triangles in there that basically could merge into two and could repeat. That is basically hiding from you. So we're going to change the question from how many triangles are there to how many congruent pairs of triangles we can find. We're going to use color coding. For example, normally you wouldn't really have the math part, you wouldn't really refer to a diagram. You would only refer to the proof that is given to you. But we're just going to ignore that for now and see how many congruent pairs of triangles we can find. For example, we can say that CBE can be 1, and we could also say that BDE can be 1. So in equation form, triangle BCE is gonna be congruent to EBED. So according to this diagram right there, we can say that those two triangles are congruent. But remember how we said that there might be overlapping triangles? Well, there's another pair that we can find out, and I'm going to try and do that in the color red, since that's our favorite. This triangle right here, BCD, we could also say that ECD are congruent. So now we have two triangles that overlap those two triangles. So we can say BCD can be congruent with ECD. Type in the comments below what you think, if there's more pairs you can find out, or if there's less. But hang on, there is another one we can find out. This is going to be our last one because we're going to use these skills to solve a proof. So we can say ACE, and we can say BED. So basically, so we can say is ACE, and then we could also say BDA. And they can be congruent. So ACE, BDA. So there may be more combinations where you can find congruent triangles that can overlap another. Type in the comments below if you can find more, and type in the comments below if you can't. The reason why we did this is not only are we going to prove this in a proof, but overlapping triangles can be seen in real life with engineering. For example, if you wanted to engineer a bridge, you gotta find somehow to keep that bridge up there stable. It has to hold something. If it isn't, it's gonna collapse. Triangles in the engineering world are the most powerful shape because between all forces compacting and compressing on them, it's very hard for them to actually fall apart. since if one triangle goes missing or breaks, then the other triangles can cover or overlap them. So triangles can make triangles, which can form triangles, which can form even bigger triangles. Here's an example.
A shortcut. Cut short. It didn't fall?
Okay, that was a video from Hot Wheels Highway 35. It showed a bridge with triangles, and even though some guy tried to destroy it, it would still be able to withstand its weight because of the powerful shape, triangles. So now let's start on the proof. So given RC as a segment is congruent to segment RK, so RC is congruent to RK. RS is congruent to RO. So RS is congruent to RO. We have to prove somehow that CS is congruent with OK as segments. So we have to prove that this line and that line are congruent. But how? Let's put in our given phases on first. Okay, so here are our given phases. RC and RK are congruent as segments, and segment RS and RO are congruent. But now what can we think about our triangle? Question. If we're trying to prove that OK and SC are congruent, then what can we do? Well, it says that RO and RS are congruent, and it also says that RC and RK are congruent. That covers basically the entire triangle. But we could also say that there are two triangles that are on the same angle R. So we're gonna say that angle R is congruent to literally itself, angle R. And the reason why is reflexive. So there appears to be two hidden triangles that use the exact same angle R. So we're going to use purple and orange. We can see that RCS is a triangle using angle R. And we could also see that triangle ROK can be using the same angle R. So we gotta find a way that those two triangles are congruent, because it has a segment right there and a segment right there that we're trying to prove that is part of those two hypothetical congruent triangles. So if we have an angle right there with the same angle for angle R, two triangles that use the exact same angle, take a look at it. Both triangles have a segment, an angle, and a segment, which means we can literally say it is SAS. And we can say triangle RCS is going to be congruent with triangle ROK. But hang on. We now have two triangles that we now proven that are congruent with segment, angle, segment. The last thing we get to do now is, since OK is a segment for the orange triangle, and since CS is a segment for the purple triangle, and we've proven that those two triangles are the same and are both congruent, we can literally say we got our answer. Segment CS is congruent to segment OK because of corresponding parts are congruent to triangles that are congruent. C, P, C, T, C. So all we had to do was notice the entire triangle, find an angle where two hidden triangles are using, then use SAS to find two congruent triangles with different colors, and then find out and get our express train to our answer and what our proof was that we proved. And that is how we can use overlapping triangles to solve a proof and to engineer something very, very big. I hope this video has helped you understand overlapping triangles. Thank you for watching Tao Ping Life's Math Industry. Like and subscribe.